information carried by electromagnetic waves and their reception. It is a common experience that sound waves 20 Hz to 20,000 Hz in air can be heard only over short distances. When long distances communication is needed, and the free space is the communication channel. And antennas radiate and they receive the signal. From the theory of the antenna, it turns out that antennas operate effectively only when their dimensions are of the order of magnitude of the wavelength of the signal being transmitted. For example, an audio tune of 4 gigahertz, when converted into its electrical analog, that is, when passed through a transducer, corresponds to a wavelength of 3 times 10 over 8 10 over 5 meter, which is certainly an impracticable length of an antenna required for the transmission and reception of a tone of 3 gigahertz. The required practical length of the antenna may be obtained by the translating or shifting the electrical analog of the audio tone to a higher frequency. In foregoing paragraph, we have discussed the transmission of an audio tone problem regarding the practicability of the antenna and the possible solution. We now discuss another problem whose solution once again needs frequency transmission or shifting. During conversation, we generate an audio signal which has a range. Suppose the audio range extends from 20 Hz to 10 gigahertz. The ratio of the highest audio frequency to the lowest 10 gigahertz is 500. Therefore an antenna is designed for one end of the range would be entirely too short or too long for the other hand. Once again, we can overcome this problem by shifting the audio signal to a higher frequency. For example, the audio signal is translated to a frequency of 10.6 Hz. Then the range occupied is from 20 Hz plus 10.6 Hz to 10.4 Hz plus 10.6 Hz, yielding a ratio of 1.0. Therefore, translation of an audio signal allows the use of same antenna for both the lowest frequency and highest frequency of the radio signal. The transmission of intelligence, that is voice music code, is accomplished by translating the electrical along corresponding to the intelligence signal with a high frequency radio wave having constant amplitude and a fixed frequency generated locally by the transmitting equipment. The process of combining audio frequency AF and radio frequency RF waves to accomplish translation is called modulation. The higher frequency wave having constant amplitude and a fixed frequency is called carrier wave, whereas the audio signal is referred to as a modulating signal. Therefore, modulation is a technique by which some characteristic of the carrier wave is varied with time in accordance with the modulation signal. Mathematically, a carrier wave is represented by the sinusoidal wave form. Okay, so this is the remaining section till the phase modulation.